Hello, geometry students. Here's your lesson for section 3.5, slopes of lines with Missy McCarthy, Okemos High School math instructor. By the end of this lesson, you should be able to say that I can find the slope of a line from the graph or from 2 points on the line. I can use slopes to identify parallel and perpendicular lines. I can articulate the correspondence between the direction of the line and the sign of the slope, whether it's positive or negative. And I can find the slopes of horizontal and vertical lines. So we're revisiting some of the things you guys did in algebra. You will need graph paper for this lesson and for the next lesson. So I suggest just going to Googling coordinate plane. All kinds of images for coordinate planes come up, and what I usually do is just grab some of those images and throw them in a Word document and then print off graph paper. So that's one thing you can do. All right, so we're going to talk about the slope of a line, and the slope of a line is the comparison of its rise to its run. Okay, so when we talk about rise and run, we're really just talking about the steepness of that line, the steepness of the line. So we measure the rise. If you choose one point on the line, I'm looking at this point here, x1, y1. And if you choose another point on the line, x2, y2, the rise is the change in the y values, how far you go up or down. And then the run is the change in the x values, how far you go over. And if you do the ratio of the rise to the run, that's what gives you your slope. Now there's one important formula here that I want to make sure that I highlight, and that is the slope formula. It says to find the slope of a line, to find that ratio of rise to run. If you have 2 points, x1 and a y1, x2 and a y2, so you have 2 points that are on your line, you can compute the slope of that line simply by doing y2 minus y1, subtracting the y coordinates, and x2 minus x1, subtracting the x coordinates. So here is a very important box, and it has the formula for how you can compute the slope if you're given 2 points. Okay, so we're going to use the slope formula to determine the slope of each line. So for the first line, we're going to do line AB, so we need the coordinates of A and B. For A, it looks like it's -2, 1, 2, 3, 4, 5, 6, 7. -2, 7. And the coordinates for point B are 3, 7. 3, 7. So if we're going to find the slope of this line here, line AB, we have to do the difference in y, or the change in y, over the change in x, or the difference in y over the difference in x. So I'm going to do m equals, we use the letter m to represent slope, and I'm going to subtract my y values, 7 minus 7. Then in the bottom, I'm going to subtract my x values, 3 minus a -2. So we end up with 0 over 5, so it looks like the slope of that line is 0. Now I'm going to focus on line AC. Again, my coordinates for A are -2, 7, and my coordinates for C is down here at 4, 2. So now to find my slope, I'm going to subtract my y's on top and subtract my x's on the bottom. So I'm going to do 7 minus 2 on the top, 7 minus 2, and -2 minus 4 on the bottom. So it looks like I end up with 5 over -6. So it looks like my slope is -5, 6. What that means is if I start here, I should be able to go down 5, 1, 2, 3, 4, 5, and go over 6, 1, 2, 3, 4, 5, 6, before I get to another point on the line. And that is indeed correct. You see that that path took me from point A to point C. All right, lastly, we're going to find the slope for AD. So again, we know that A is -2, 7. That was point A. And point D is here at -2, positive 1. Okay, so now we're looking at line AD, which is this line here. Okay, so when I find my slope, I'm going to do the change in y, or the difference in y's, or subtract my y's. Lots of different ways you can say it. On the top, 7 minus 1. and -2 minus a -2 on the bottom. That gives me 6 on top. That gives me 0 on bottom. And this is not possible. You can't divide by 0. If you try to do it on a calculator, you're going to end up with an error message. And then we say, if that's the case, where 0 is in the bottom, that the slope is undefined. So here's just a couple things to remember. If your line is increasing from left to right, like this first example here, then you are going to have a positive slope if it's rising from left to right. If the line is decreasing from left to right, you will have a negative slope. And I believe we saw that in our previous example with line AC. If the line is horizontal, if you have a horizontal line, there is no increase. So therefore, you will have a slope of 0. We saw that in the previous example as well. And lastly, if you have a vertical line, then the slope is too steep to measure, and we would say it has an undefined slope. And we saw that in the previous example as well. Okay, so slope can also be used as a rate of change, and that just means that you're going to give it units and you're going to talk about how fast something is increasing or decreasing. So if we look at this example, Justin is driving home from his college dorm at 4:00 p.m. He is 260 miles away from home, and at 7 p.m. he's 455 miles away from home. So we graph the line here that represents his distance from home at any given time, and we're going to find and interpret the slope of this particular line. So I already have my points. They have 4 and 260 and 7 and 450. So 4 and 260 is my first point for X and Y, and 7 and 455. Okay, so to find the slope, I'm going to do the same thing that we have done before. I'm going to do the change in the Y's, 455 minus 260, and the change in X's, 7 minus 4. So when I do my difference on top, I do 455 minus 260, and I get 195. And then on the bottom, I get 3. So I can go ahead and divide that 195 by 3, and I get 65, and I could put that over 1 if I needed to. Now, what does that mean in terms of this problem? Well, the Y values we were measuring on the side were miles. And the X values we were measuring across the bottom were hours. So if on the top was my change in Y, that was in miles, and on the bottom was my change in time, that was in hours, that means that the kid, Justin, was traveling at a rate of 65 miles per hour. So we have found and interpreted the slope. All right, just one last thing here about the slopes of lines. One of these is called the parallel lines theorem, the other the perpendicular lines theorem. The parallel lines theorem says in a coordinate plane, if you have two lines that are non-vertical, they're not vertical, then they're parallel if and only if they have the same slope. And any two vertical lines are also parallel. For perpendicular, the lines will be perpendicular if and only if their product of their slopes is -1. Vertical lines and horizontal lines are always perpendicular to one another. So parallel lines have the same slope, and perpendicular lines, if you multiply their slopes, the product is -1. So let's take a look at using these two theorems. So we're going to graph each pair of lines, and we're going to use their slope to determine whether they're parallel, perpendicular, or neither. So we've got a graph line UV. U is 0, 2. V is -1, -1. So there is line UV in blue. Now I'm going to grab another color pen. I'm going to grab purple and do line XY. Point X is at 3, 1. And Y is at -3, 3. All right, so here's my other line. It is right there in purple. Now I have to tell whether or not these lines are parallel, perpendicular, or neither, and I'm going to actually find the slopes. They appear to be perpendicular, but I'm going to find the slopes to make sure. So the first one I'm going to do is I'm going to find the slope of line UV. And that's going to be my change in y, so I'm going to do -1 minus 2 over my change in x, -1 minus 0, and I get -3 over -1, which is the same as 3 over 1. Now I'm going to find the slope of line xy. So I'm going to do my change in y, which is 3 minus 1, over my change in x, which is -3 minus 3, and I end up with 2 over -6, which is -1/3. So I know they're not parallel because my slopes are not the same. So what I'm going to do is multiply my two slopes and see if I get -1, and if I do, I know they're perpendicular. So I've got 3 over 1, and I'm going to multiply that by -1 over 3, and when I multiply those two, I actually get -1. So because I get -1, I can draw the conclusion that those lines are perpendicular. If you multiply the slopes and you get a product of -1, that means that they're perpendicular. Okay, here's another example. Let me grab a different color here. I'm going to grab red, and I'm going to do line GH. So G is -3, -2. That's here. H is 1, 2. That's here. So line GH is here in red. Quickly grab another color pen. I'm going to grab blue again this time. And I'm going to graph line IJ. I is -2, 4. So there's I. And J is at 2, -4. So it's there. So here are our two lines. So let me grab my red pen again and find the slope of line GH. Change in y is -2 minus 2 over change in x, -3 minus 1. I end up with -4 over -4, and my slope is 1. Grab my blue pen here and find the slope of line IJ. Change in y is 4 minus a -4. Change in x is -2 minus 2. So I end up with 8 over -4, which is -2. My slopes are not the same, so I know they're not parallel. The product of my slopes, if I do 1 times -2, I get -2. I don't get -1, so they're not perpendicular. So therefore, I must draw the conclusion that these lines are neither parallel nor perpendicular. All right, so you already know your I can statements from the beginning of the video. We're going to start class tomorrow with this lesson quiz. So if you want to try some of the problems now, you may do so, or if not, I will see you in class tomorrow.